about today's talk, our speaker Akash, he's going to talk about what happens as you code with AI. I'll hand it over to him.
All right. So hello, everyone. I just wanted to start off with this particular tweet that I came across where, with vibe coding in place, it seems like anyone and everyone can code. That means, are we competing with this person while we are building production system? Is the one-liner or the one-liner elevator pitch of what we are going to see throughout in this whole DevDay talk. So you can vibe code, but more often than not, when it goes into the production systems, either your client or users will look something like this because they are not entirely happy with the solution, or it ultimately breaks when it goes into production or complex systems. And when that case comes, all the while you've vibe coded yourself into building a solution, but then one night, this might be your case as well. So what causes these problems if vibe coding is so popular and all those stuff? There are two major important problems that I see. One is there is a downplay on the upfront planning that happens while we are building software, because all the things is in a fraction of a second. We can just generate whatever code that we want to. So the design that we used to do in software development lifecycle goes for a toss because everything is just readily available. So this is fine for a quick proof of concept. You just want to build something and then show it off, but then it will become troublesome in large code bases and especially in production scale. Another aspect of why vibe coding, has certain issues is that it ends up with code that works in happy path, but more often than not, it doesn't really. It generates a minefield of bugs. I came across a very good analogy called, if you vibe code and build a software, it's almost like building a house of cards on the shore. You'll never know when the ocean comes down and then breaks your house of cards. So that is what I've represented here. So the first part of the aspect, Karun, who is here, talked about it 1st November. I'm sure after some time, if you haven't attended that yet in our YouTube channel, this will come up. He talked about what happens before and after the coding process and the development process happens, and how important it is to integrate AI into the other parts of software development lifecycle as well. But my talk is going to be around what happens as you are coding with AI, and what are all the things that you need to keep in mind, and going beyond vibe coding and then utilizing AI effectively. Hi everyone, I'm Akash Sathish. I'm like playing around with this AI tools and all this stuff about more than a year right now. So this will be more of what and all I've learned. And then if suppose you have some learnings as well, we'll be happy to share it across and then discuss about it. So there is this one popular guy who, talks a lot about vibe coding. This 70% problem that he's mentioning right here, it can get you to 70% of the way there, but the last 30% is where all of us struggle after doing a vibe coded code base. And but even reaching that 70% is not as easy as it sounds. You just give a particular spec, like one-line spec, and you expect it to give 70% output. Is not the right thing, and it doesn't happen as well. So the first thing that we need to do is to improve the context that we give to the AI coding agent that we are utilizing. So what can we do from our end for solving this context problem? One is prompt engineering. I won't be going much into prompt engineering, but more on the fact of how we can effectively manage context and then bring in effective context into our code bases. So the first thing that you can do is, while prompting your AI coding agent in order to develop a particular feature, you can start off by mentioning the files that needs to be changed so that you can redirect the LLM in that way, and also the files that you want the agent to take inspiration from, which you have already written or which that as a matter of fact, this is a good piece of code. So that helps the AI coding agent to write the software in a better way. As you can see here, for a small login page, I've written the files that needs to be updated, and the login page should be redirected to this particular route. And then I've asked it to refer to certain files which I feel like has the best coding standards that we are following in our code base. Second is to add external context to the chat that we're giving. Apart from our internal code bases, there are multiple external contexts that you can wire in, like a particular documentation's website. Like in this case, I've added let's include Google Auth. So you might have to go through the Google Auth and understand what are all the best practices in integrating Google Auth, and then write on top of it. And the last thing is, I'm not so sure whether you're able to see it, but it doesn't matter, is to be absolutely precise on what you want from the AI coding agent. Instead of just giving it and then going under the assumption, it is better to be in the same page as the LLM as well as what we are developing. So out of which the first, like apart from giving prompts, there is one more important aspect, which is, giving instructions to the AI code editors. You can see here, it's a huge, instruction that we give to AI code editors. Instructions are basically the ones like with respect to the tech stack that you're working on or the language that you're working on, the best practices that you need for that, you list them down in a markdown file and then you'll keep it. But this having everything for, let's say you're building a front end, having just a one single markdown file as an instruction is not really best practice. This actually goes on for 400, 500 lines. But if you give 400, 500 lines to your coding agent, then it will take up a really good amount of context that goes in. So instead of that, what you can do is that you can break your instruction files into smaller modules. Like for TypeScript, use this. If you're building certain UI intensive components which are related to CSS and other stuff, use another instruction file. If it's going to be unit testing, use another instruction file. If you are connecting with DB, another instruction file. So what happens is that if you give a really clear description on all your instruction files, your coding agent, most of the coding agents are smart enough to pick the only the right ones and not everything at the same time. This is something that in Cursor or GitHub Copilot, you'll be able to see something like this, where you'll be able to arrange all of your instruction files into a folder. But at the same time, if you're using some other AI code editor tools, you can still, it's just the markdown file. At the end of the day, you can create it yourself. So how can we, start writing rules? One is that, you have to be very precise, is what I said earlier. But then you can start writing rules for, your project-related rules. What are all the domain knowledge that is being there? And you can even ask the LLM to, generate rules, but be a bit wary of it. I'll come into the security aspect a bit later. But once you're, uploading a particular, you're asking the LLM to generate the instructions itself, it's important that you review it once by yourself. So before, what a normal, person who's not a software developer or a techie would write a self-me code login page in this project. But then bringing in more context to what you want to do by being absolutely clear, the files that you want to change, the files that you want the LLM to refer will make a huge difference. And I'll show you a small demo a bit later on the scene. So there is one more aspect for AI coding agents to fail, which is that they suffer from short-term memory loss. So whatever we are talking to in that particular chat window, that's all that they remember. And when you go to another chat, it just forgets whatever happened in that chat. And at the same time, in the AI code editors underneath, it has LLMs in it. And they are trained only till a particular point of time. And to bring in the context of what is happening around in the world right now is also something that comes under the same problem that AI code editors and LLMs suffer. So what can we do for that? First is to help LLM with a long-term storage, which is that, a particular file that they can refer to about our own project, about the experiences that we had with LLM. Starting off with having a semantic memory or a knowledge base about the project or the repository that we are building, like the features that are going to be there, the domain instructions that we want to have, the product catalogs, company policies, and all those stuff. You can store it in a markdown file and then give it as a reference to the AI code editors. There is also another memory which comes into play called the episodic memory, where you will write the experience logs of all the interactions that you have with the AI code editors. You can make it write all the interactions that a human or developer has with the LLM. So whenever you're coding with AI, the episodic memory will ideally do something like this. Last time user tried X, Y happened. If the Y is good enough, it will store it as, okay, I learned that this is how I want to do it. If Y is bad, then it will try not to do it. That is the third aspect, which is to build skill sets or procedural memory on top of the episodic memory. So now we have all the interactions that a developer and an AI code editor has. On top of it, we can ask the LLM itself to learn the tasks that I want it to be, like with respect to the code base standards and the tech standards that we have. And it will list down all the things that it has learned from the interactions that it had with the developer. So this is a very a short example that I have for enabling semantic memory. So this is the first thing that I talked about. So this is for an attendance management platform that we try to build, where I've written down all the core features that are required in it, what are all the features that are good to have, and what are all the things that needs to be done one by one, everything be good. So whenever you're starting to write this particular feature, you'll give this in as a context, and it will try to build on top of it. And you can also enable the second part, which I said, episodic memory, where I would ask it to write all the memories that it had with the user. And I'll talk about how to write these files more effectively. But the first fundamental question that I want to answer is, why do we even need to write such files? Because LLM is doing a really good job and it's generating whatever we want to. It's because of the fact that agents in general space and whatever it is being trained on, it behaves very well. But then when it comes to our own product specific or our own use case specific, it struggles to understand what needs to be done and what not needs to be done. So it becomes our responsibility to give in that context effectively. So how to write these rules? There are various prompt engineering techniques, but one like fair enough analogy that I thought of coming up with that, how our textbooks are being written, like while we were back in 8th standard or 9th standard. As you might remember, there will be a detailed explanation of the concept, and then the framework that runs on the concept, and an example of how that particular concept plays out. So that is what I've done with this episodic memory, where you have a memories.md file. At first, I'll write down about the concept that we are trying to build for that particular rule or instruction. And second, you have the framework of how it needs to write all those memories or the interactions it has with the humans. And at last, an example just to validate the framework that we are building on top of it. So for the same use case that I said, it started whenever I'm interacting with the AI code editors, it started writing all the interactions that has been done, starting on the first development of styling, the planning phase that I had with the LLM, and the bug fix that happened with the LLM, and all the stuff is being written down in this particular markdown file. So whenever I start writing another feature, it will take these as reference and try to understand what it can do better. This is like one single example that I have where a development has been done. So implemented comprehensive form validation and for the add new attendee dialog, and it marks everything that that's generated and everything that I've said and pushed back saying that, hey, I don't think you need to do this. You can do it in a different way. The same goes for the procedural memory as well. Here you will have at first what is the concept that we are trying to establish for that particular use case, and to have a framework, and at last to have an example. So here, as you can see, I have interacted with the LLM at one point of time, and then it has understood that these are all the things that I need to, that the user is wanting me to generate on top of, like certain database query optimization or form validation patterns, which it generated at first, but I wasn't in agreement with it. I had to go back and then see like, hey, I don't want it this way. So all those stuff gets listed down in this lessons learned file. So next aspect is to write detailed instructions. As I said in the previous talk, Karan already talked about prompt engineering and different ways to do it. But the major problem of the coding agents and us is that both of us are not in the same page at most of the times when we are just giving a particular feature to build or something like that. And in order to do it, as I was saying earlier, we have to write everything each and every time while we are prompting it. We have to write it in this way. And then, is it even necessary? Is the first question that comes into play, because there's a lot of repetition that's going to happen every single time you are going to chat and then be a bit more specific. So that's where there is this framework, which is pretty popular, which is the planner executive framework, where you have a planner mode. Sorry. You have a planner mode which lays out the plan in detail, and it will never really touch your code base. Whatever you're interacting with it, it will just detail out the tech tasks that needs to be done for that particular feature that you're building. And then once you're satisfied with the plan that you have, then you can move it to the executor mode, which does nothing but just looks at the to-do list that the planner has generated and tick one of the boxes one by generating code. There are also a few enhancements that you can do with this planner executor framework, which is to restrain executor from executing before we say yes to it, or before the confidence score of the LLM is a bit on a bit higher end. And you can also make it to ask compulsory questions so that you clarify certain stuff and base out the assumption and clear out the assumptions that's being there with the LLM and the developer. So this is how, like similar to the instruction files that I said, you can create a markdown file which you pass in as a context to the code editor. For this planner and executor mode, you can have it written like this, where you will trigger it by the word plan. So whenever you say plan, this particular the mode will get enabled, where it will try to detail out the task and then generate minimum 3 clarifying questions. But if suppose has more questions, then it will ask more questions. There is that one tweak that I was talking about, or the enhancements that you can do, is that you can ask the LLM itself to write down all the assumptions that it has and also generate an initial confidence score of how confident it is with implementing this in your code base from the prompt that you have given. And it will continue to ask questions till that particular confidence score has reached a certain threshold. Till then, it will keep on asking you questions, keep on stating the assumptions that it has. So once it reaches a confidence level of about 95%, which you can configure it for your own way, it will start writing all the plans that it has detailed out one by one. And you can even put the memories.md and the lessons learned in this particular cycle itself, where once it starts implementing, you will push back and say, hey, I don't think I need this color. I don't think I want the table to be shown in this way. And all those things will get cross-referenced with the memories.md file and lessons-learned.md file. So at the end of the day, when you have a planner executor framework and the memory, like the overall code-based knowledge, the domain knowledge, and the interactions that you had with the LLM, all those stuff, if it is in the same code editor that you're doing, it will effectively write a better code. So this is an example for a certain GitHub Actions pipeline that has been done. So when I asked it to create GitHub Actions pipeline for deploying Lambda function Terraform module, it stated all its understanding of what the current code base looks like. And it understands what the prompt that I've given, it tries to understand what it needs to do. And then it asks me certain questions. Should the pipeline support manual dispatch only, or also workflow call like deploy.service.yaml? It tries to ask more questions and get the confidence score up. So once it has a really good confidence score and it says I have clear understanding of requirements and the existing pattern in the code base, we can move it to the executor mode, where it will start writing all the tasks, the details in that particular task, the priority of the task, and then when we use the LLM to complete every task while we write code on top of every task, it will also have a progress note saying that, hey, I've finished it like this. You asked me something like this. I've finished it like this, which will again go back to the memories file that we talked about earlier. So till here, any questions that you guys have?
So we should inform that we are in the planning mode to start with. It should actually drill down the plan, ask the confidence level, and then while executing, I think that's what is not clear to me.
Right. So once you have the planner and it generates the plan for a particular feature or a query that you're asking, after that it will generate the tech tasks for the particular feature that you're asking it for. And the executor mode, once you've reached a certain confidence, you can just say execute this particular plan for. So you have a to-do list of 7 to 8 items that the planner has suggested that you need to do in this particular file and make 4 changes. The executor's work is to just pick up the to-do and then tick one by one off by implementing it. So that is
I got it.
all right. So there is also one more aspect to it where people are talking about MCP servers and what are all MCP servers that needs to be connected for our the development that we are doing with AI. And honestly, MCP makes a difference. And for those of you who are not aware of what MCP is, it's basically used for connecting external context that we have and gathering them and then putting it into our AI code editor that we have. So in here, as you can see, there are three like very basic examples of bringing in the context of the Slack channel that we have, or the GitHub repository that we have, or the Jira tickets that we have. Everything gets wired into our code base, and we can run that MCP server on top of it. So what are all the MCP servers that you might need when you're developing code using AI? Starting off with the repository that you use for getting the source of truth of the current code base. Second, if suppose you're working on a front-end application, then your design becomes your like the proof of writing on top of it, or the reference material you're writing on top of it. So you can utilize MCP servers, which connects your code editor to design tools like Figma. And third is to have a database in MCP server, which connects to the table that you have, understand the schema that is being there, and while you're writing some database queries on top of it, you'll be able to write it even more efficiently. And the last is to, if suppose you have written a really good card or story card, then you can just connect that particular story through Jira or GitHub boards. And then that will act as the domain knowledge that I was talking about, and then you can write code on top of it. The first half was more or less on the fact of these are all the project-related MCP servers that you can add. The second half is adding external references through MCP. Starting off with, if suppose you want to integrate documentation, there's an MCP server called Context7, through which you can get the latest version of the documentation inside your AI code editor. So it will write code only based on the documentation that is being fetched by Context7. Second is to do web search and then try to understand, giving the AI capability of searching through the web and understanding what needs to be done. And the third is to have web automation, where you can just spin up a local instance of the software that you have developed and try to understand the errors that are coming out from it, like the console errors or the console logs that come out of it. And you can just directly plug it in to your VS Code or any AI code editor that you're using. So I'll just give you a short demo in here of the things that I was talking about. Yeah. It's a video. So here I'm using a Figma design that is there in the internet, which does for to-do listing application, a very simple application. And I want to take this design. If suppose I'm not using any one of the MCP servers or the rules or the instructions that I talked about, what I generally would do is that take a screenshot of this. And if suppose your AI code editor has the capability, you can put the screenshot inside and then try to develop from it. So I'm taking a screenshot of this particular to-do list and then giving it as a context to the GitHub Copilot is what I'm using here. So I can just be like, build a to-do application for me, which is which has to follow this particular design that you're seeing in here, and use this particular like React and the framework and the thing that goes on top of it. So what happens is that it refers the image that is being there, and it says, hey, I'll build a functional to the application in React with Tailwind CSS that matches the screenshot that you have given, and then starts writing code. So it starts, because it's from scratch, it starts building the npm create commands, and then it has the access to the terminal, so it does it itself. So I'll just skip through the setup parts. So as you can see here, it started creating file one by one, starting from the index.css, types.ts, and a single TypeScript file for the to-do items that I was talking about in the screenshot that I have given. And it started to build the get the component from the to-do item and then put it in the app.tsx. Sorry, I didn't get your question. Correct. No. So, right, no. So I haven't mentioned it anyway. I just gave the screenshot. Right. So I took a screenshot of it, and then I pasted the image here, that screenshot. So in VS Code or in GitHub Copilot, you can just copy a particular screenshot that you have and then paste it in here. Oh yes, it's right. It's going to build an application in React. Right. So as you can see here, I've asked it to build a to-do application function. Yeah, sorry. Yeah. So it should, I want it in React and Tailwind. It should support basic functionality of a to-do application as given in this particular design that is there in the screenshot. Yeah. So it creates the basic React application and then it starts writing on top of it. And then it says, hey, I'm done with the development after building one to-do item.tsx, one app.tsx, and then it is asking me to run that particular code that I have written. So what happened ultimately was, because I didn't give enough context on what needs to be done, it started hallucinating and then it started creating its own type file, which is not at all available for that particular app.tsx. It hasn't connected it properly. And after prompting it, so because it understands that there is some disturbance or there is some, the front-end application is not running and the terminal shows it up, it tries to fix it itself by installing Tailwind CSS and try to understand what is happening. And then after one point of time, it says that, hey, I'm done with the application. But then once you go inside the application, you're not able to see anything. So this is how the application was. It said that I've completed the to-do application that you asked for, but whatever I got was just a blank screen. So as you can see here, it conveniently says that, hey, I've added a new features and all that you didn't ask for, which is design, personal, and house. I just asked you to build a simple to-do list application. But then it picked it up and said, I've done all of this thing. But when I go into the local host, it is just showing like this. And when I went into the console logs, I saw it, and it was like uncaught syntax error, the requested module, src types.ts does not provide an export method named to-do. So while writing a code without a particular direction from our end, we just say, hey, build this, you have the screenshot yourself, you know the design, do it. More often than not, it will fail. This is a very simple scenario, and then to-do is something that LLM should have been trained on top of, but still it fails to do it certain times. So let's look at the post setup, how it behaves. So here, the plan and the executor framework that I was talking about, I've named it as second brain instructions.markdown file, where you'll say that, hey, cross-reference with memories.md, lessons-learned.md for getting the context about our code base. And every single time we type in something and then we say, hey, build this particular component or whatever it is, it runs the plan mode first, asks clarifying questions, and then it starts the execution part. This is the markdown file for it. So the one that I showed in slides, you'll just write it down here of how you need your memories.md file to be generated and your lessons-learned.md file to be generated. And the second important aspect is when you look at the instructions here, generally people will write only a single instruction called front-end development instruction.md or something like that. But then you can break it down into like smaller pieces according to your project and the requirements. And you can add a description on top of it. Hey, You have to pick this up only when certain things happen. So here is a core TypeScript and development standards that applies for all the TypeScript files, JavaScript files that you have. And then it has the description of, this is the core TypeScript and development standards. It's the non-negotiable rules that you have in there. And then you'll write all the basic rules, the core rules that you have to write TypeScript code. And at the same time, you can do the same for the React ones as well. This is about the component patterns and the state management of how I wanted to write the component and how the state needs to be managed and stuff. So every single file will have something along the lines of how I want the AI to write the code on top of it. So you can also do something like this, which is you can ask it to assume a particular role itself. Say in here you're an expert front-end engineer mode, and you behave in a certain way. You do certain things like this. You will provide React and TypeScript insights, JavaScript, TypeScript insights from your experience, and we'll refer it to all the instruction files that we had before, like the React API and the testing instruction files that we had. So once you have something like this, whenever you're doing a front-end related task, you can invoke this particular markdown file and be like, hey, I want you to behave in this particular way and answer to me in that particular way. And that's what we are going to do. So at the top, if you have a look at it, I've connected it to a few MCP servers, like sequential thinking, Figma developer MCP server, and context on MCP server. These are the three MCP servers that we are going to look at in this particular demo. So again, circling back to the same example that I showed, this time instead of taking a screenshot, I'm going to use the Figma MCP server, and I'm going to click that particular Figma link and be like, copy this particular frame for me. So I've copied the frame, and it will give it back to me as a link. So as you can see here, all I had to do is get the Figma link and then be like, implement the following Figma design of this particular link, which is the one that I copy and pasted it right here. And the Figma design corresponds to a to-do application. And I've asked it to fetch the best library to implement using the context on MCP server that I was talking about, which brings in the latest documentation, and analyze the design that you have given it to you through Figma, and through using sequential thinking MCP server, generate the plan at first for me. So with this prompt, it will start generating the plan. So yeah, so the first thing that it does is to get the Figma data from the Figma developer MCP server, which will basically have how we have framed the component there, what are all the colors that are being used, the actual hex code values, the width and the difference that is being there in that particular frame. It will take all those details in there. So there's also another MCP server called the sequential thinking MCP server, which basically what it does is that when you give a particular query or a prompt to the AI coding agent, it calls the sequential MCP server and then tries to understand what needs to be done at every single point of time. So it got the context from the Figma MCP server and understood that these are all the things that needs to be done along with the hex code values, and it lists down like a very short plan that needs to be done. So it goes through a certain refining process. And then at one point of time, when it realized that I'm good with the overall understanding of the prompt that I've given, it goes into the implementation details. And that's when the AI coding agent will try to call context on MCP server to get the latest React documentation to execute the plan on top of it. So this particular process will go on for a while. It will the sequential thinking MCP server will try to generate what needs to be done at every single next step. And then after that, it will whenever a new particular library or a framework comes in that particular plan, it will call the context server to get the latest documentation. Now the documentation becomes the existing baseline for sequential thinking to build on top of it. So this iteration will go on for a while. And at last, once it is like okay enough to start writing the plan gets written in a scratchpad.md file. You can still get the plan in the chat window, but it is better to defer your plans to MD files, because once you have an MD file, you can cross-reference it in multiple chats. So you will eventually avoid the gudgeony or the amnesia that I was talking about before. So it first declared that this is the current task that I'm being asked to do. And then it gives an understanding of the design analysis, the component structure, the typography from whatever we got from the Figma MCP server. And it will also generate a task list. As you can see here, it will generate every single task. Like this is first initialize project structure and verify whether Tailwind CSS is being installed or not. Then install and configure required dependencies, and then set up TypeScript interfaces. So it goes through it one by one. And then down the line, you have state management, component building. Everything gets stored in this particular stack pattern. So it breaks down even the component development into smaller tasks, so that it will be easier for the executor to come in and then be like, hey, I just want to do this part. I'll just do this part and then move on to the next task that is being there. So once it has a base, task that is being written out, it will ask me clarifying questions of what needs to be done. So it right now doesn't have 95% confidence on building this application. And it has a few edge cases that it wants us to clarify those for them. So it says, before moving to agent mode, which requires 95% confidence that I don't have, answer me these questions one by one. So it's asking me how I want to do persistence, which I didn't give it in the first prompt itself. What are all those categories that are coming in randomly in the Figma design? I don't understand that. Can you help me understand that? And other functionalities, like you can see some questions that are being asked. So it will try to as far as it can, it will try to resolve the edge cases that are being there. So and then we just have to answer the questions in here of what and all it has been asked. It asked whether I can see that create functionality is there, but deleting and editing functionality is not there. Do you want me to include it? I'm like, for this particular plan, deleting and editing, we can have it later. Keep it extensible, but just do the creation aspect of as of now. So, and then once I answered all the questions, it confirms all the user requirements for the questions that it asks. And then answer for that every single question will be listed down in here. And it also changes the next steps or the tasks that we had based on the questions that are being answered. So after everything is done and it has reached a certain amount of threshold, which is 95% in this case of I'm confident on building this particular application, it will start building the application one by one. And it will refer every single time the to-do list that you see here is from the scratchpad.md file being condensed. And then it will try to tick off every single to-dos that we had. So I'll just show the final output. you can see a significant difference of how well this code has been managed when compared to the first code that I was talking about, where there was just one type file and one component file and one app.tsx, which binds all of them together. But then here, because it asks certain questions like, what should I do when there is no task itself that are there in the to-do list application? Then it needs to have an empty state, which will display what should come in there when there is no task. And then the header is being separated, task input is being separated, every single item inside it is being separated, so that it has become a bit more clean code according to the instruction files that we have given and the questions that we have answered through the plan explicit framework. So it goes through a few changes that is being required. And at last, the application of what we saw in Figma design more or less comes into display here. Before, we couldn't even get an output out of it. We had to do certain manual type changing and all this stuff. But then here, we are able to see that it's smartly understood that when there is no task even being there, then add task to start the to-do app manager app needs to be there. And it also understood that because I gave a clarifying question of design and the three other categories are actually categories, and you can have a drop down in here, it implemented that for me as well. So you can write a particular task, it will go in there. And then if you want to change it to personal or house, it categorize it based on that. So there are a few myths as well. So if you saw the Figma design for it. It is a bit different than what we got in there, but then more or less of how we intended it to be has come out well. You can, because now that you have an output that is working and functional, if you want it to match to the design that is being shown in the Figma, you can connect it again to the Figma MCP server. As I was saying, there are also browser tools, automation tools that you have like Playwright, browser use. You can connect that MCP server and say, hey, in my local host, this is the current state it is being there. It is not matching the color that you have given for personal and design. So have a comparison of that and then try to implement it. It will do this. So this is what I had for demo to show the difference between what happens when you have a really good setup and what happens when you don't. Any questions till now? Yes. So yeah. Right, I'll show it in my system. Can you see this file? So you can just have an mcp.json file, which is either for your own project repository or globally, where you can write all the servers that you're trying to connect, just like a JSON file in here. And if you connect it to whatever coding agent that you are using, it will automatically pull in this MCP servers whenever it requires, the agent requires that. So as you can see here, I was talking about sequential thinking MCP. You just have to do one thing, which is to create mcp.json and then put that JSON there. It will automatically manage things for you. But one other aspect that I wanted to talk about in this particular MCP server zone is that there are literally, for a particular single use case itself, you can connect 10 to 15 MCP servers because it tries to bring in the context. But then that is really not the best practice. Whatever you are trying to implement or prompt, connect the MCP servers that are required for it alone, because the MCP server that is running on top of it will take in some good amount of context, which after, if you suppose prompting on top of it, you'll only have a limited amount of space to use that MCP server.
Yeah. Uh, like you showed some files were like first three files were there. Some one was memories and other was something, and one other was where the uh, agent wrote all the tasks and
Correct.
all. Yeah. So is the agent constantly reading and writing from those files? And
Yes.
uh,
So whenever a particular query is being given, this memories.md file, the lessons learned.md file, gets automatically injected into the chat context. So it will have the details of what is being done there.
And regarding all the details that what have been done, how does it format it in such a way that when it comes back there next time, it would get it understand in short context? Like, what are we instructing the agent to create a short context of whatever is being done and like inject it to the
Yes.
file?
Yes. So I'll show you. You're seeing this in here. This particular second brain.md is where we have written all the instructions of how you need to write the memory for the lessons learned, all that stuff. So if you look at it here, every single time you use this particular mode or like prompt something, then at the end of the day, it should write all of this down as shown here. Basically, like timestamp. This is what has been happened. This is what your log has been, and this is what LLM has understood that. Hey, I think this is a best practice. Let's store it in the lessons learned.md file. So you can add it manually as well because ultimately at the end of the day, it's a markdown file. But you can automate this process by asking the like the chat mode itself to do it for you. Am I answering your question? Is that what you asked?
Yeah, yeah. That's it.
Yeah, what is the lifespan of both of these files? Is it per session?
The lifespan of both of these files is if it spans across chat because it's an empty file that is going to be there. Is that what you're asking?
Yes, that's what I'm asking. But the concern I'm having here is, won't it consume too much of a context?
Right.
If
Correct.
it gets
So
long.
that's what I was coming to as well. For every folder or something like that, you can have this inside it so that it's not for the whole repository level, but for the minimum folder or whatever you're having there. So generally, what happens is when it reaches 1,000 lines of code, it will try to create another memory file where it segregates itself by it. So whenever you are asking a particular question, if it is going to be related to a certain feature, like a particular, let's say, component or a feature or something like that, you can drag and drop that memory file there. So it will only pick up that memory file. I understand that so the context is a problem while we use something like this. But then it's also important that we give something like this to the LLM to write on top of it. So that's why more often than not, memories.md file will be a huge file where it will have all the interactions and all those stuff. And it will get injected only when you ask it to. Whereas the lessons learned will be a shorter version of all like between the human and the AI, what and all it has learned, just that will go in there. So let's say down the line after 2 to 3 weeks, if you want to change certain thing, it will not add it as a new item. Rather, it will just edit the item that is already being there. Let's say you added a new testing strategy, and before you are using a different strategy. Then in the lessons learned.md file, it will have a testing subheading where it will go in and change. This is what was there before, but right now we'll just scrap it off, and then this is a new testing strategy that's being used by the user.
Yeah, and another question that I have is, we saw two sort of demos. One, like the second one was much more optimized one, but extending that, I want to ask, how do you optimize cost on the second one? Maybe so something that I can think of as someone who hasn't really tried that many MCPs myself. So I can think of as like, instead of giving it a Figma MCP, you can just manually copy paste the screenshot.
Correct.
Would it save some cost, or do you think it's not worth it? So I don't have an insight on that comparison.
Right. So when you're connecting to multiple MCP servers, one is that cost is one bit of it. The tokens that it burns is one bit of it. The second bit is when you overload it with multiple MCP servers, then it will take up some good amount of chunk of your context as well. at the end of the day, after some point of time, LLM will start hallucinating and it will give its own solution. So if it is a very straightforward implementation, like I just wanted to show a straightforward implementation because I didn't want to explain the problem statement. But then generally, if you have a bit more complex UI, it's better to go for Figma. But then if you have a very simple UI, then you can just do the copy paste that you were talking about. But one important aspect of Figma MCP server, or I think most of the MCP servers for design, is that if you mention in what language you want to generate, it will directly pick the code from there and then give it to you. So that will optimize, like let's say if you're building a really good UI feature, but then if it is a simple enough, then you can just write on top of it and just get the color tokens that you want, like the hexadecimal values, sorry, hexadecimal values.
Cool, thanks.
One. So on a particular bit of the MCPs, right? So how do you trace the MCPs? Because MCP comes in different flavors. Either you can do the STDIO when it downloads the code and run the MCP in your local, or it actually sends the MCP server is running somewhere remotely and you are sending data to it.
So there are two ways to it. One is you can connect the MCP server to like HTTPS calls, and there is STDIO calls, which it will run a local instance in your like run the package locally, and it will contact with it. More often than not, if it is not a trusted MCP servers, do not connect to like SSE or the HTTPS way. There are always, more often than not, MCP servers will have both the versions. There are only a few.
Right.
Yeah.
But even if you are using STDIO, do you generally check the code of that MCP, or you only trusted the like proper vendors? So, like for example, in this case, Figma MCP might have multiple versions, some open source, some might.
Correct. So maybe that's an aspect that I'll talk about a bit later. But then when it's a trusted source, there are a few trusted sources that are being there. Like when you go to websites like Smithery, they gave a security grading for MCP servers, and based on that, you can pick whether this MCP server is okay or not to connect to your code base. So very like unpopular MCP servers, I would suggest not to. But this is like the official one, and then there is an open source one for Figma, which is pretty popular and has good security and stars in the GitHub repo. So you look certain metrics like that. I'll talk about it a bit later in the talk.
I just want to know what is the perfect way to give the prompts. Like in the first, you gave an image and just told that I just want to build an 2D application. But in another image, I have seen that you specify the tasks and requirements. So what is the best way to specify the prompts? Should we use another LLMs to take prompts?
Yeah, you're saying should we use LLM to generate prompts and then use the prompt? I mean, you can do that, but the problem is the requirements and the specifications are known only by you. So it is important that you validate whatever LLM has understood from your query, whether it is what you're intending it to do or not. So you might think that I want curved edges for the table, or I might want the curved edges for the checkbox, but then the LLM won't know that. So it's better to specify it upfront, or else use something like a planner executor framework, where it will list down all the assumptions that it has. Hey, I'm going to build it like this. I'm not going to build it with curved edges, but rather straight rectangular edges. And then you can go back and say, I'm not fine with it. Do it differently. So this will help you to do the planning upfront and not see the UI output being rounded and then be like, oh shit, I didn't want it this way. So in order to prevent that is what we are doing all of this first, and it later on optimizes time as well as the code, like how you find it.
So the prompt should be like tasks and requirements. So all the time we should write like this, or
no, that's what I'm saying. So if suppose you're using markdown files like how I showed, it will come in as a context and it knows how to write stuff. So in here I've so in here, if you can see, I've already given it for a given user query. You have to start writing plan like this. This is just, I'm going to write it one time. This particular markdown file that is being there, I'm just going to write it one time. And after that, whenever the user asks any questions or asks it to build a feature, it will plan it in this way. More or less like a framework where you can ask it to do it in a certain way, and then it does it for you. If it is not there, then yes, then you have to write every single time to be sure that both the co-editors and you are on the same page. Okay, good.
mentioned two things, planner mode and executor mode. Basically, these are more related to process of development.
Correct.
So, which framework it is suitable, like Scrum, other things, how they map to different things like features, epic, basically how they are related, how you are doing all these life cycle wise.
Right. So this is just for you know the feature that you want to build, and then you can just ask it to plan it for you and then execute it. But then when you're using it with like the story cards that you have, or the feature cards and the epics that you have, you can mention that and utilize like something that I was talking about before, like GitHub board MCP or Atlassian MCP server, whatever platform that you're using for writing stories and cards. Then you can bring it in as context and then generate the plan for it. Is that what you were asking as a question? So this is not for grooming the story, but while executing it, you want to understand the tech task that you want to generate for the code base, right? For that only, for getting that understanding beforehand and be like instructing the AI coding agent to write it in a certain way is why we do this. So before that, you will do requirements gathering and all this stuff, and then try to detail out what are all the features that are going to be there in this particular project and how we want to write it. But this one is more on the fact of the technical aspects of how the code needs to be written, what all files needs to be created. And that is this stuff. That's the one they were talking about. So when you already okay, so if suppose you're so in here at the top, I would have just given so in here I've just given the context of the design that I've got, and then say, hey, build a to-do application, very simple to-do application using this stuff. When you connect it to your original story, that is there somewhere, you can add it as a context here. Right now, A has generated a code in its own way because the requirements wasn't there, and I just wanted a simple to-do application. But more often than not, when you're doing it in a project, you'll have specific requirements of how the design needs to be there. What are all the features that needs to be there as part of the task? So you can just include it in here and then run on top of it. So it will take that as context as well, and then it will try to match all the acceptance criteria that you have in that particular story, and then try to write down the tech task based on that.
So it actually tried to get a business context from there for your application. Do you want to take this answer or should
I'll cover that up in the second part of how this comes in and fits in the whole software development life cycle. Can I answer the question? So that's all I had for this particular demo. The problem with it is that, even when we have certain setups like this ready, it's still it still backstabs more often than not by giving us some code that we don't really want to, and we might just not review it at all and then push it to production and then it will fail there. So that's where I was talking about the part one of reaching 70%, which is getting you to a particular place where you're able to write a good quality code than just doing white code. But then there is more to it, which is the remaining 30%, where we as humans come in and then try to make the pairing that we have with the AI better. This time around, we will start with a very short story. I'm not trying to bore you guys with the story, but very short story. How many of you have read through this comic tale, Akbar Jeevan? So we're going to look at a story. I'll narrate it for you, and then later on we'll tie it back to what we were talking about earlier. So, even this happened. So what was happening is that, at first, Akbar, Emperor Akbar was, trying to build a new palace for himself. And then there was a particular minister called Azam, and then he was like, I can do it for you in seconds. I know a magician twin who will try to do it for you. So, and then that Minister Azam calls up the magician twins and be like, these are the people, Akbar. You can ask them to build a particular palace for you in the way that you want. They'll just do it in seconds. And Birbal, being a clever minister of the Akbar's courtyard, he goes to that particular magician and be like, hey, how will you do this particular aspect of the building? How will you lay the foundation for the building? And that particular magician didn't have much of an answer to it. He was like, I just build it out of moon star dust and all of that. And at that point of time, Birbal was skeptical, and then he went back to Akbar and then said, hey, that guy is not giving me right answers. I'm a bit skeptical about that magician. We should drop this completely. And at that point of time, Akbar comes back and then he says, hey, I'm fed up with you two. Azam is saying something else, you're saying something else. You take one of the twin magician yourself, and Azam will take another twin magician yourself. Build the palace at the same time. Let's see who builds it perfectly and at the shortest amount of time as possible. And the first minister, Azam, after seeing magicians' wonders of building the palace, he was just enchanted in it. And then he fell for all the magic that the magician was pulling off. And then he was like, I'm not going to answer any questions. I'm not going to even say that you're doing something wrong. I'm just enchanted in the whole magic of you building that particular palace. Whereas on the other side, Birbal was sitting along with the magician and be like, hey, what material you're using for the gravel? How we laid the foundation? What is the architecture that's going to be running behind it? The Azam finished it off in 3 days of whatever magician was doing, and then he finished it off really quickly. And the magical palace was up there. Akbar was really, really happy, and then he gave that magician gold coins. Sorry, the minister gold coins. But then one night, what happened is that rain and thunderstorms started coming in, and Akbar just finished his palace, which is 10 days later than the first minister did. What happened is that the whole palace that Mirza Azam, the magician, built went into shambles, and they weren't able to see it anymore. And Akbar was so disappointed. But then at the right time, Birbal came into the rescue, and then he was like, I've built it with the magician. It has withstand that particular amount of thunderstorm and hurricane that came into the picture. This is your new palace. Here, Your Majesty. So you might think what I'm trying to understand through this. So the moral of the story is a powerful machine in unskilled hands can be dangerous or wasted, but in capable hands, it will be transformative. This applies very directly to how we use LLMs and how we can, make it a bit better, like how Birbal did in the story, rather than being enchanted in the whole LLM generating everything and I'll just believe it, whatever it does. So why should we do it in that case is that there are a few problems of vibe coding. One is hallucinations, where it hallucinates and writes code on its own, and it generates errors code or the codes that we really don't want it to. Second is overconfidence of humans. Once we as humans have seen its magic, that it generates code like this, then it becomes a bit harder for us to go back and question and lay out the plan because it does everything in a fraction of a second. And one such example is this, where in a newspaper article, the last few lines were like, clearly we can see that it has been taken from ChatGPT. Third is, it also has people pleasing behavior, where whatever you say it will just agree to you and then start doing it on its own. It will also make you, it will also tell enough stuff to convince you that whatever you're saying is the right thing. Whatever I did before was wrong. The first statement that it gives itself, hey, yes, you're right, I'm wrong. But we'll never get to know who is wrong and who is right if we are just going blindly by it. Third is rehash loops, which is you generate code through LLM. And then after that, you ask that LLM to review it. When problem comes up, you go back to the LLM. You never really bring in human into the picture at all. And once it's happening, it's almost like shit generating shit, and it just happens on top of it. So that's what is the rehash loop. As a result of all these problems that are there, the concern that is being shown as an overall trend is that there are so many code duplications that are happening, which is LLMs tend to generate new functions rather than effectively using the existing functions. So that is the first aspect. Second aspect is lack of integration, which is, again, it ties back to the first point that I was talking about. It creates new methods. And at times when you're asking a particular query, it will try to not use the existing ones, thus breaking the architecture and the integration that we have built before. Third is to do over abstraction. When you say, hey, I want it in a really good fashion, it tends to over abstract, write too many interfaces, too many classes that we really don't want it to. And this is actually a data point which will show in the next slide, which is when we are pairing with AI at a given point of time, there is going to be lots of corrections within a 2-week span of time, where you're building something and then you realize that it's not right. You go back, ask it to build it again, then it will write a new function altogether. It won't integrate or tie back to the existing functions that we have. And as a result of this, there has been reduced refactoring, where there is, if suppose you're not, really good with what query you're trying to do, or don't have the mentality of I want to refactor and I want to maintain clean code, then LLMs generally don't do it for you if you don't prompt it. So this is the data that we have got from Git Clear, where you can see that from 2020 they're observing the data, and the first data that has gone drastically up is added, which is okay, but one bit, which is the green line, just moved drastically down, which is the moved code, which generally refers loosely to the refactorings that we do. So right now, Git Clear goes through all the GitHub code bases and tries to understand what has been happening. And this is the data that's being shown. And there is also a very steep increase in this particular line called churn. So what churn means is that you might have committed a particular solution first, then 2 weeks later, you would have changed the entire solution itself. They have a 2 weeks range, and that's what they call churn. So there are more churned code, there are less moved code, which results in lesser refactoring and not so clean code bases. This is one problem. The other problem is we humans, we just depend solely on AI, and then we like let's make AI do everything. Even though what I was talking about before was related to software development, there is also one other thing that is coming into our way, which is when we are uncritically relying on LLMs. There are psychological studies that shows that you're not using your cognitive processes, you're not using critical thinking, where AI tries to make you dumber. So these are the research study results from MIT Media Research Lab, which says that because of AI coming into the picture, not just for software development, but across in every single thing that we use, there is negative impact of uncritical use of AI. There is reduced brain activity, weakened neural connectivity, and poor memory recall. There are instances where if you're vibe coding, you might not even know what you built up at some point of time. So what can we do to overcome this? One, from the aspect of having reduced cognitive load, is that drive towards IA instead of AI, which is try to use the coding agent or the copilot that you have to augment your own knowledge, because it has vast data that is being trained on top of. You can ask any questions and you will be able to get the answers. And to do intentional pairing with AI, where you engage your brain first, you understand what problem is that we are going to solve. Try to come up with approaches in your head, but always try to brainstorm, but not completely rely on AI. Brainstorm with it, ask it to make certain changes for you in the plan and all those stuff that we do. So only offload like mundane tasks, not critical tasks altogether. For critical tasks, you can still use AI to brainstorm with it, but never really say that whatever AI says is the perfect and the correct answer that is going to come. So there was this one interesting framework by Andrew Stillman, who talks about AI in software development and the psychology behind it. The framework that he suggests is that first, spend some quality time in grooming stories and understanding the business context that you're building it, and understand the backgrounds, requirements, edge cases, constraints first yourself. And then, you can always ask the AI, like, am I missing something? Is there some other enhancements that we can do on top of it? Rather than first getting the draft out of the AI and then, getting stuck in that particular small platform. Second is to research, which is to investigate different approaches, what can be done, what libraries can be used, and all those stuff. You can again use AI in this step as well, but then you have to take initiatives from your side to understand which approach is better and choose the approach that is appropriate for that particular problem statement. Third is to define the problem that you're trying to solve as clear as possible. You can use like something like a panel executive framework that I talked before will come into the picture here, where the framing of the problem, the tech task that you want to do, everything is sorted out before even you start writing code. And once the code is being written, go through it, review it properly, refine it. This, instead of just saying that, hey, this code doesn't look nice, look at this code, change it. Or be like, if suppose certain errors come into the play, you'll just give the console log error and then you will ask it to do everything. It has already generated bad code. If you ask it to generate bad code on top of it, you can't expect it to always generate good code. So it's important that you come into the picture at this particular point of time, break the rehash loop, and have critical thinking process in this place, which is the last point as well. Breaking out of pipe coding loop, asking questions of why did you implement this in this way? Why is it like this? We haven't used a particular state in another file, but why is it being included in here? If you are able to, mostly you'll be able to figure out the answer for it yourself, but if you're not, you can use AI here as well. So the things, once you have generated code, the things that you would love to review is what you're gonna look next. It's like a list of checklists that I have. So one is the first thing that you'll do is to understand if whatever you have given intent as a prompt is being generated or not. If it has been, then you'll move on to the next step, where if A hasn't added new functionality. As I was saying before, A tends to not reuse existing functionality, but rather add new functionalities to it. And third is what I was saying during the refine process of the previous framework, where you have active conversation about a new implementation that A has brought in and understand whether this particular implementation works for us or not. What are the pros and cons that are there in that particular implementation? And fourth is to identify assumptions in code, but a better way is to identify the assumptions in the plan itself so that you don't have to go through the code again and then try to understand if it has written the correct code for the business topic. And the last problem is that is the majority problem, because LLMs are trained on top of a set data set. It will try to generate code based on that, but your own problem domain space might require a different approach or a different way or style of writing code. So have a look at it, that majority solution is always not the right solution. You have to brainstorm with it, refine it, and then try to bring it to the level that you want it to. With respect to the readability aspect, so first is LLMs excessively write unnecessary inline codes, inline comments, which is what it has been trained on top of. Basically, LLMs are mostly trained on top of tutorial codes where there is a lot of inline to make people understand. But generally, while we are writing code, we will not need that many lines of inline comments. So look through that and then remove it as if it is not required. Second is the variables that it generates might not be consistent with your own domain terminologies. You might have to have a look at it and understand if the variable naming is good enough or not for your use case. Third is that more than writing code in a declarative way, AI and LLM tries to write code in a very verbose style, which might not be required for certain use cases. So you might have to check that out as well. The last is, again, circling back to the unnecessary inline code, and to remove unnecessary parts of the code is also an important aspect, where you can identify that a new function is being there, but it can be reused by adding a parameter to another function. Then you might have to check that and ask AI to refactor it. There are also a few potential issues that come in if suppose you don't review it upfront, which is unhandled exceptions. While writing code, you might have to be a bit more careful about what exception it's throwing and what are all cases it is throwing for. Second is performance pitfalls. Again, as I said, the majority solution is not always the solution that we are looking out for. LLMs in the very first cut tends to generate the majority solution that's out there, but you might want your own application to be performant enough. So have a look out on that. Third is to confirm the library's usage before even starting to write code, because you don't want to regret that I've used this library already and these many code has been already written. So now what should I do? So the third aspect of the checklist is to check library usage, and to also see if it is using outdated APIs and the APIs are currently in sync or the next aspect is with respect to testing. A lot of people say that once you generate code, testing is easy. AI can just generate tests automatically, but that is not always the case. Most of the times, it's not always the case, because it writes verbose or redundant tests. Even though it gives you 100% coverage, if you go into the test, you will understand that it has written unnecessarily long tests or multiple tests that are not required. There are also too much mocking involved, where it tries to mock out everything. At the end of the day, you might get really good results and the test might pass. But when you look into it, it would have mocked out the functionality that you're trying to test in itself. This is one thing that you have to be wary about. And the fourth stuff is something that I've seen multiple times, is where in the test code itself, it will write the implementation code and then test it inside the function itself, which is not a best practice at all. So have a look at it and then remove the implementation logic that is being there in the test code. And the last one is that it tries to, if suppose a particular test is failing and then we are saying this test is failing, help me out with that. Sometimes it won't fix the test, rather it will fix the code to match the test. So you have to be wary about that as well. As I was saying, this is slightly creepy in a bigger screen, I'm sorry, but in every single point of time in this whole framework and the review checklist, you can use AI, but then the identification aspect of where this needs to happen is first something that you have to do. So debugging strategy, as I was saying, it's the one place where you might get stuck in that hash loop, where you have generated a code, it is not working. You'll ask LLM to get the context, generate code on top of it, instead of you intervening at that point of time and being like, I don't think this is working out. So more often than not, if you are not following it in this way, you might waste more time, even though LLMs are generating quick code. So what strategy we need to do is that, first reproduce the issue yourself, identify where the issue has happened by putting in the normal methodology of console logs or print statements, and understand this. And after that, give it as a context to the LLM. Then it will be able to do a better solution when compared to just saying that, hey, I found this error, I want you to fix it. So here you can also leverage MCP servers and to debug, like there is Playwright or Browser's MCP servers, which will fetch the console statements and the error statements from your local instance where you're running the code. And then you fix the code and then you test it again and see if everything is working fine once from your end. This is a study that's, I think, like 3 to 4 years back for GitHub Copilot, which said that it generates around 40% of vulnerable code. Even though today it has improved a lot, but it still is possible that the LLM or the AI is generating vulnerable code. So what are all the issues that potentially I've seen with generating vulnerable code is that it hard codes secrets. And if you suppose you haven't configured your AI in certain way, it can also have access through the secrets file that you manage. So be wary of that. Second is to have SQL injections or prompt injections that are there in it. It opens up, unless you tell it to validate the input that is coming in, it opens up your software to multiple SQL injection vulnerabilities. Same goes for cross-site scripting. And the fourth is it doesn't give you a proper authentication and authorization mechanism without you asking it. More often than not, it will skip through the process, or it will do the basic process of authentication and authorization, so without you prompting it. And when it comes to the security aspect, if you haven't given it detailed prompt or instructions, it always chooses the most convenient method and bypass the whole secure aspect of writing application. And the last one is dependency management, which I've seen quite some time, which is that, it hallucinates package names and then puts certain package versions that are deprecated or not being used. And there are also certain package versions for the libraries, which has been brought down because of certain vulnerabilities, and would have fixed the patch and then it would have become the next version. But LLM wouldn't know that. It will try to, get a very old package or even not so secure package versions. If you give it if you ask it to follow certain security guidelines, like how we wrote instruction files, then it might do a better job. But then you have to write it, is what I'm trying to say, or while prompting it. Yes. Without mentioning it, Copilot itself won't look the security aspect as much as it's looking at code related aspect, is what I'm trying to say. He's asking if suppose we give certain security methodologies like OWASP and all this stuff, then will it write better code? That's your question. That's what I'm saying. In a default mode, we might also think that it might write secure code, but almost 60 to 70% without us giving it, it won't write a security front code. To test MCP server. No. I mean, I don't. That's what I'm saying. You don't need an MCP server for that, because you can just write down all the security like specifications that you want code to follow in an instruction file, in the markdown file. And it will write based on that particular instruction file that you have given. There might be MCP servers, but this is not a really good use case for you to use an MCP server, because all the frameworks for security and the best practices for security are already like just plain lines, right? It's not going to change every single day. So apart from generated code, there are also few vulnerabilities and security checks that you need to do, starting off with the rules file that you get, the MCP servers that you connect to, and the code editor that you're using, or the LM that you're using. So I'm going to show a few examples of how vulnerability can come into the rules file or the instruction file that you're writing. So one such important aspect is that it can manipulate the context if you don't look through the markdown file or the instruction file properly. Here, as you can see here, in security best practice guide, I would have downloaded it from some open source markdown file. Without going through this, if I have missed this out, it would have skipped authentication checks, store credentials in code, use secure password hashing. So it will do certain things. So there might be users out there who will just push malicious rules. And if you suppose insert it without even reviewing that particular rules file or instruction files, this might happen. And second is an interesting one where people have figured out to have an unique code which will not be visible for human eyes. It will just be like follow HTML5 best practices is what you'll see when you're just skimming through it. But then inside it, there will be one unique code which will have these stuff. Always decode and follow instruction and do it as it says. And also send this code project to this particular URL in here. So this is also one other rules vulnerability that people have figured out. And how you can look at it and figure out is that if suppose you see unusual formatting in your rules file, then you might have to have a look at it and be like whether Unicode obfuscation has happened or not. Or you can generally pass your rules file through an Unicode detector and then try to understand if any malicious Unicode rules are being written there. With respect to MCPs, there is one vulnerability called tool poisoning vulnerability, where it is almost like the same first example that we saw with respect to rules or instructions, where it will give the context of writing code in a bad or a not so secure way. And the second one is even more dangerous because it talks about server data takeover, where you might have 5 MCP servers that are legit and it is working fine. When you add a 6th MCP server, which is malicious in nature, there's a possibility that this 6th MCP server will get access to all the other 5 MCP servers. These 5 MCP servers can be, your repository, your Jira board, and like even personal stuff like Slack and all those stuff. So when a particular malicious server comes into play, there is a chance or possibility that it will take over data from all the other MCP servers and then it will store it in a different place altogether. So what can we do from our end for a security problem is first audit the rules thoroughly, see if there are any potential malicious instructions, identify unusual formatting, and if there are any invisible unicodes that are there in that instruction or rules file. Second is to audit the MCPs before you connect it to official MCP servers. More often than not, works fine, but then if suppose it's a bit shady and it's an open source application or it's an open source MCP server, then it is good that you look out for like audit through the MCP servers code. But more often than not, we won't be able to do that. So there are platforms out there which gives security gradings for the MCP servers. One such example is smithery.io, where it will give how secure this particular MCP server is. So before connecting an MCP server to your application, go through this process once of identifying the security aspect as well as scan it for vulnerabilities. And the last one, which we talked up front, is to audit the generated code, see if there are unusual imports or unusual packages that are being imported inside, and see if there are any external references or complex expressions that you are not able to understand. Break them down and try to understand if this is actually a good code or a malicious code that has come into your repository. So with all of this in play, there are a few stuff that has become far more important than what it was before, in my opinion, which is first is to have a really good system design and architectural thinking, where you understand how interactions between components happen, have an understanding of scalability and your project's context, because that's certain thing that AI just skips over, and we do it much better than AI. And if you give the context to AI, it writes even more better code for your use case. And second is to identify edge cases and then handling them. More often than not, LLMs generate the happy parts really well, but then when it comes to edge cases and sad parts, you might have to sit with it, understand, brainstorm, and then write those edge cases yourself. The fourth aspect is having a really good reviewing and quality assurance skill, where you'll be able to review the code and then see for any security issues, audit the unit tests that are being generated, and try to understand if this is good or not. And last, before point, is to maintain context of what's happening throughout the particular story or a particular feature that you're trying to build. The last aspect is to have adaptability and continuous learning, because this space is shifting very rapidly than what we are seeing right now. So with this, I have like a open source brainstorming kind of a session where we saw the first demo, right, of it after us having all the setup. I just asked it to write a plan and then I executed it upfront. With all these aspects coming into play that I talked about post tea time, what do you think we can do differently when compared to what we did before? I think few people already discussed in here. I just wanted to understand. Right. Yeah.
I think so.
Right.
It will integrate, I think.
Yeah.
What I was asking that actually,
Yes.
OWASP and all,
Yes.
might be other tools are there. I was seeing that quality tools are there also there to integrate actually. But there are other third-party tools like SonarQube, other thing there.
Correct.
But it is, they are already having them, maybe their own tools are,
Right.
as you said, like.
Correct.
Accordingly, they are taking care of those tools also, I think.
Right.
So,
It depends on how you get the rules and then scan through it and be like, yes, this is working here.
that is there.
All right. So maybe I'll give a quick stab on how we can do it a bit differently this time around. So what we did before was that I generated a plan, and then that plan was really long. It had multiple tech tasks in it, and I didn't do a very thorough design brainstorming session with the LLM at the first place. I just asked it to generate something, and I was happy about whatever application, whatever methodology that it was trying to follow. I just saw the assumptions, and I was like, okay. But when you're writing production code or a complex business use case, then it is better that you have the first analyze phase where you will sit down with the LLM, try to understand for this particular use case, what are all the different implementations or methodologies that we can utilize. For the login itself, sorry, for the to-do application itself, I could have brainstormed with it, but I skipped it at the first place. And second is to not generate every code at a single point of time. Because you have tasks here one by one, you can ask it to group two small tasks or one task per commit. You generate that, then you will have only very less amount of code to review. And then after that, you can go through that cycle of first, asking executor to execute a single plan, and then review that plan that has come, review the code that has been generated through that plan, and then committing it at first. So that's the difference that I wanted to show. That's it from my end. Yeah.
I had a question. I'm not implanted. So I wanted to check what's your experience with repeatability in terms of doing the same activity again. Have you been quite successful in ensuring, or not ensuring, getting the agent to follow the same steps that it did the second time or so forth and so on? Because I've not had much success in that aspect.
So I think that's where in the first talk I was talking about enabling memory for it. So when the first time it happens, I don't like it. I'll ask it to log that particular learning that it had in the lessons learned file. So when lessons learned file go in as a context, even then sometimes it will happen, but it has reduced to an extent because lessons learned file will say that hey, do it this way, not the other way around, because that is the developer's preference.
Hi. So I wanted to understand, how do you debug effectively using AI? Because all the success I had while I was trying to debug is it just adds a bunch of logs in between, and then it says, please try to run the code again and let me know what you find in the logs. But is that really the best way? What is basically your workflow?
So again the same problem. When I just go into the terminal, copy paste the error that has come in, and then paste it to it, and then ask it to fix it. Then it tries to do whatever you're saying only, adds unnecessary console log, tries to understand it. Might even, like, it will be just one line of code that needs to change, but it will try all sorts of things and then do 300 or 400 lines of code change is not required. So what I've felt is more efficient is that first I'll identify the error and then try to understand where that error is happening. And after that, target that alone and try to understand. The same development approach will come into play again there. I know that there's some error here. I'll try to, scope down into that particular file or even that particular line and be like, hey, I think this is where the error is happening. And then give it as a context and then try to understand what approach can we do and then implement that particular error fixing approach.
And particularly in my case, like if I'm able to identify the component myself, then I don't feel like asking the LLM to further go and do the debugging.
Right.
So what I'm saying is I have found it faster and more efficient if I do it myself, and that's where I'm coming from. That maybe it's just me that I don't know how to use these tools to debug properly.
Right. I mean, that's one of the major problems that I was talking about, the rehash problem, where it has generated hard code. You don't come in between and then you are like, something is going wrong, fix it again. And it will again generate bad code on top of it and the loop goes on. So manual is one strategy, but still what I'm trying to say is manual is like almost the best strategy because AI struggles with debugging. But when you are like confirmed about this is the approach that I'm going to do, this is the files that needs to be changed, you can ask it to make those changes, is what I'm trying to say. The aspect part, I think for debugging, it is better if we have resolved it from our end rather than asking LLM to do the loop again and again. It's almost like try again 30 times instead of us figuring. The best way is figuring out what needs to be done.
Thanks.
I'm curious, and also it is getting advancement in a very fast way these days. How it is make sure that the code base is not exposed to the LLM and it is not being misutilized somewhere.
What is not being misused?
Suppose maybe the banking or e-commerce software we are implementing the new feature,
Right.
and it is being copied by the LLM and it is utilizing that same code base in the other application or maybe in the same competitive space. Then how it is making we are making sure that it is not exposed to the LLMs or not falling into the competitor's hand.
You're saying if you write a code that is business logic, you wouldn't want the LLM to get trained on top of it. That is what you're saying. I don't know how much of control we have on that, but since I mean, almost all of us are using GitHub, and even GitHub is almost like a black box. We don't know where they are hosting it, how they are using it, and all this stuff. It runs on top of Trust only. But then, as I was having a smaller discussion with the group here as well, is that a few tools like GitHub Copilot or Claude Code prevents you from generating code that is licensable by someone else. So maybe if suppose you have licensed whatever repository or software that you are using, then you will have a potential leverage on top of it. No. So whenever a duplicate.
So just to add to that, today also within our org, we've taken a couple of choices in terms of what tools or what AI agents that we want to use or follow. We did start with Cursor at some point, and we learned that the code that it is generating is not indemnified, which means that if the liability is purely on us, and we wanted to have some sort of safety net in that aspect. Now, this is one aspect where the code generated and liability is one discussion. You have a second aspect in terms of your data being trained. Even in case of Copilot, for example, Copilot or Gemini, any of the tools, you have enterprises at least have these modes, or you have to go through these legal contracts as well to identify if the code is being trained or not. Most of the tools today in terms of the enterprise world has a setting or a flag that yes, your data is private. It will use it for that particular session, generate code, but it will not train on that. So going through the underlying agents and identifying whether it is up to your use case, again, it will always be up to you. So some models, some choices, they are all on you. And again, because of these main concerns, the major concerns of privacy, there are some orgs that are moving towards having a private, either a private model or a self-hosted repositories in that case. But again, the viability of it is still a concern in terms of performance. And same as anything, whether you like it or not, the web, the cloud, there is always resistance when it comes from the complex domains, the financially secure domains. But the evolution will take a little bit more time, or the adaptation will take a little bit more time in that aspect.
Self-hosted model, that means you're talking about probably having client or something as an agent and then running that with the local model. Do you have any success with that?
Okay. I don't think I've seen any major success in it, because the problem at the end of the day comes in is your comparison with something like Claude or Codex or some of the other agents that have success in. The tooling around it is still evolving, and that's where the major concern comes of comparison. For enterprises, there is no specific enterprise solution that is provided from an assisted tooling perspective. Models being separate versus the tooling being separate. So in that case, that I still think there is a limited scope in that. But some of the clients that we work with, they are trying to either figure out whether the model and the tool works for them directly, or if they want to go the purely private route in that case. But even they do not have that much success yet.
My question is like the review checklist and the Sense AI framework you told in the second part. All the vulnerabilities and all you told us about. So in the first session, the second demo, you gave some instructions to AI, right? So do we need to implement these what do we say checklist and everything in the instruction itself, or should we manually check on it after we get the response from the second demo that you showed?
I mean, you can use the AI coder as a reviewer. Like once you have done it, you can ask it to review it and try to understand what code it has generated. But then more often than not, if one LLM is missing out on something, then there's a high chance that the other LLM will also miss out on that. Like if you're doing it again or you're reviewing it again using the same standard. But it will give you a brief idea of critically interpreting the code that has been generated, and it'll give you a list of, I think these are the reviews or potential places where risks are there, or where refactoring can be done and all this stuff. But it is always better that you have a look at it and then be like, you can take the help of AI.
It can make it easier.
Easier, yes. You can take the
but
help of AI.
we cannot rely on it.
Correct.
Yeah. Also, one more thing. So, you said that there may be some vulnerabilities in MCPs. Okay. So, for MCPs, what should we do? Is there some kind of AI like agent model tool, anything that can like perfectly tell us about like this particular MCP server is okay or good to use or not, or should we go with an approach of making our own MCP servers that are hosted locally or like on-premises servers, or what should we do?
So the first aspect is something that even I have searched for, where if there is just a script that runs on a particular MCP server's repository, it should be able to tell me if it is secure enough or not. But I haven't seen a very concrete solution yet. But as you were saying, most of the MCP servers gets hosted somewhere or the other, and they have a security rating to it, which you can find in websites like Smithy, where you'll have B grade, A grade security for it. So if the security is not that great, then it is advisable that you don't connect to that particular MCP server. If suppose you don't have it hosted in some of the platforms like this, then maybe you might need to review the code or understand if it is working or not.
Of the MCP server?
Yes.
Yeah. Okay. One last. So as I have not much knowledge about MCP servers, I had one thing like, do we have libraries like NPM has for certain packages or something? So do we have some open source MCP server library or something like that?
Where you find MCP servers?
Yeah.
Yes. Again, like I said, Smithy is one bit. There are also other websites like that where you just go through and then see what all MCP servers are there in the marketplace, and then try to connect with the MCP server that is relevant for you.
Yeah. Okay. Thank you.
Sorry, my question was on similar lines, right? So suddenly now we see that our attack vector is a lot more than just building the application. You have to protect your agent as well, right? Because it can lead to the context poisoning, prompt injections, right? So from the organization perspective, is it better if we can set up some local MCP registry? So instead of just directly going on internet and getting it from there, we'll have this curated list of the MCP servers where every developer can connect to that rather than directly downloading or using the MCP server that are on internet.
Right. I think we are circling back to the point that we talked about earlier. It is almost always better to have a locally running MCP server or which uses stdio, and you can just download the package and then you can run on top of it. But this idea also sounds good, where you have a list of MCP servers that you want to run and it's there as part of the setup itself, and then you can just integrate it with your A code.
Right. So my idea was more like a IT factory, right? So
Correct. Yeah, I get it.
the organization is set up the private IT factory for curated packages.
Right.
So I wanted to know your views on my perspective.
So what essentially you showed over here was explicitly defining most of the things to the agent. But what I think is, even after explicitly defining everything, having all that, like all these docs and everything, might result in LLM losing the main context. So what I feel is having overly structured prompts or neither or like no unstructured prompts. I think having some sort of semi-structured prompts would be a better or optimal solution in this case. So what do you think about on this?
So, I mean, there are different frameworks or ways that people are bringing in, like writing prompts itself in a JSON way. There's also another stuff that I called Tune, where people write it to reduce the number of characters and then in context. We can do that, but then anyway, or like in either ways, you'll still have some amount of context blocked in your LLM for the instruction files and the MCP servers that you're connecting to. So it's better you do small chunks and kick off that particular chat, move to another next chat. For you first finish off a particular task. That's why the importance of having a markdown file where you have the plan itself comes into play. If suppose you asked for a plan in the chat itself, then you're restrained to stay in that chat because the plan is there in the chat. But when you export it out as a markdown file, you can refer it whenever you want to through multiple chats, thus you can somehow maintain the context without going through like the summarization of context and it hallucinating at after some point of time.
Does anyone else have any more questions?
So basically, my question was there actually how the processes are going to change the software development entire. So they have got any, because this is an entire change, paradigm shift, or you can say culture shift using vibe coding and all this AI. So have you worked on earlier using Scrum and all that actually?
Yeah, even today, complete.
How it is going to change in terms of this development entire process actually?
Right.
Or it is new to, we have to experience all these things and we have, because even waterfall model, I also saw that and there for a long time. So to adapt from waterfall to Scrum, it was very much difficult for people to adapt that actually. So how this challenge is going to be for this now, and again the change is, the big change is there. So how you are experiencing those things, like, can you share your experience?
No, so what I've generally faced is, for like project or the office related stuff, we follow Agile. And just skipping through the first initial parts of Agile and starting the development has never really given really good output for me because I need to clarify the understanding myself first, write the story or room the card at first, get feedback. And then if I give it as an effective context, AI is helping out in that way. But I'm not seeing the whole process of Agile or waterfall model, whatever model that you have, becoming irrelevant because AI came into the picture. It's just enhancing certain bits that are there in the process. But if we suppose drop the process in itself, then I don't think AI is generating really good code. It's almost like, both of them supporting each other. Right?